Okay, so hello everyone. For this week or for this video, the discussion that we will have is about the distributed line constant. So basically, this refers to the transmission line theory. So the primary line constants are parameters that describe the characteristics of copper or other conductive material transmission lines in terms of physical electrical properties of the line. So the primary line constants are only relevant to the copper lines and are to be contrasted with the secondary line constants, which can be derived from them and are more generally applicable. So the secondary line constants, which we are going to discuss later on, can be used, for instance, to compare the characteristics of a waveguide to a copper line, whereas the primary constants have no meaning for a waveguide. So we know that there are different characteristics na may ara ang ating mga transmission lines, and they are determined by the electrical properties ng sinaang specific na line, such as mga characteristics like conductivity sa imong wire or your dielectric constant sa mga specific na insulator. So they are also determined by its physical nga mga properties, such as ang aton nga mga wire diameter or mga spacing between sa aton nga conductors. So ang mga uh, electrical physical properties ng aton nga wire, sila man ang nag-determine sa aton nga primary line or electrical constants. So we have mga primary line constants nga kinahanglan i-consider. So first, based diri sa figure, we have series nga DC resistance. So naka-series siya. We also have shunt capacitance. That means naka-parallel siya. So shunt capacitance. So we have also shunt conductance. So G. And we have L, which is our series nga inductance. So the series is broken down into the unit sections in which ang ating mga primary constants R, L, G, kag C. So, nga mga properties are combined. So, if gin-combine na ni siya naton, we are going to call this one as lump constant. Lump or L-U-M-P-E-D, lumped constants. So, we are going to discuss this primary line constant isa-isa. So, let's start with your inductance. Okay, so we have wire inductance. When the AC input is applied to the transmission line, its inductive reactance increases with increase in frequency. As the transmission line is made of millions of small particles, therefore the chain of those particles make the transmission line behave as inductor. The presence of this inductance provides us the opposition to the flow of alternating current. This inductance is also one of the primary line constants, and it is measured in Henry per kilometer, or may ibang pagid nga measurement for or units for inductance. So uh, if we look sa illustration, for example, sa atong transmission line, so mayara kadua ka line. So since the long conductors, mayara na sila magnetic ng mga field about them kung mayara ka electrical energy nga nagapagi sa ila. So transmission lines also exhibit the properties ng inductance. So when the current flows through the wire, so ang mga magnetic lines of force naton ga-set up na sila around sa aton nga wire. So samtang naga-increase ang aton nga current and naga-decrease, samtang ma-increase ang mga current, ma-decrease na siya in amplitude. So the field around the wire expands and collapses accordingly. So the energy nga gaka-produce sang magnetic line of force sa iya nga pag-move or pag-collapse kag pag-increase naman. So back in the wire tends to keep the current flowing. So ang kakatabo sa mga magnetic field, magnetic line of force dira sa gwa sa imong mga wire, amo na siya ang ma-keep sa imong current nga mag-move siya. So we know man sa iba naton nga mga subject that there is indeed a relationship between sa aton nga current kay sa aton nga magnetic field. So this represents the certain amount of inductance. So which is could be expressed also as what I've said here. We have Henry per kilometer, or we could also have microhenry per unit length. So it is depending na lang sa kung ano nga value or kung ano nga unit of length ang aton nga gamiton. Next one, we have capacitance. So okay, we have capacitance as the transmission line is made of two conducting wires, and in between these wires, the dielectric is present. Therefore, it is obvious that the capacitance will be present in the transmission line. So the dielectric material used in transmission lines may be air, plastic, rubber, polystyrene, or polyethylene. So the capacitance of transmission line could be measured in farad per kilometer. So that is this isa sa mga unit na pwede gamiton for capacitance. So if we are if we will be looking sa two-wire na line, so pwede gid siya mag-act as capacitor. So muna di ang aton nga pwede naton siya itawgon nga or pwede siya mag-behave sang property nga capacitance. So the change sa iyang capacitive reactance is not noticeable as the frequency applied to it is changed. So capacitance also exists between sa ating nga transmission line nga mga wires. Notice nga ang aton nga duha ka parallel wires pwede sila mag-act as aton nga plates sa capacitor. So and if ever you have duha ka line B for example and then separated sila for example sang air or ano da nga dielectric, so nga nag-act between sa ila. So the capacitance between the wires pwede naton pwede niya i-exhibit I mean. So it could be expressed. So nabutang the ring which have farad per kilometer, or we have picofarad depende sa kung ano ang unit of length. So picofarad per unit length. So this electric field between the wires naton is similar to the field that exists between the duha ka plates of the capacitor. So amo na siya nga meron siya nga property which is capacitance. Okay, next one, we have conductance. So, ano ang conductance? Two wires of transmission line are separated from each other with the help of your insulating material. As each insulating material has more or less conductive effect, therefore conductance is also one of the primary line constant that is measured in mho per kilometer. Mho kay suli siya sang imo resistance which is ohm, mho. So, okay, so since wala sang perfect na dielectric, no? So, ang mga electrons pwede siya mag-move from one conductor to the other pagi sa aton nga dielectric. So, each type of the two-wire nga transmission line also has conductance value. So, this conductance value, amo ni siya ang nag-represent sang value of the current flow or leakage ng current that may be expected pagi sa aton nga mga insulation. So, in effect, the insulator acts as the resistor naton, permitting current to pass through between sa aton nga duha ka wire. So ang pag-agi sang current paagi sa aton nga mga dielectric are what we refer to as our conductance, and it is opposite sa aton nga ginatawag nga resistance. So therefore against state na nila or amo na ang gingamit nila ang unit nga mo, so as opposite sa ohm naton. So conductance in a transmission line is expressed as the reciprocal of resistance and is usually given in pwede nga micromho per uh, unit length. If the line is meron na siya depende na siya kung ang mga line is finite in length and kung ano siya na kung paano siya gin-terminate. So we are going to discuss that later on. So we will have some last property which is very common sa atong tanan-tanan. So we have this resistance. So as the transmission line is made of conducting wire, and we know that every wire has some specific resistance according to the type of materials used, the transmission line will also have the loop resistance, which is known as one of the primary line constant. It is expressed in or it is measured in ohm per kilometer. So we have wire resistance. So it is normal na niya normal na nasa for any wire conductor nga may ara siya sang property to oppose the flow of current. So as the line exhibits the property of your resistance, this resistance is usually expressed in ohms per unit length. So we have that characteristics and which we consider as the primary electrical constant sa aton nga any nga transmission line. So take note that we also have ang ginatawag na surge impedance na kinahanglan natin i-discuss mo later on, but I have here the introduction na lang of what is a surge impedance. So surge impedance or characteristic impedance of your transmission line. So if a transmission line is made infinity or infinite long, and we measure its input impedance from the source, this input impedance or infinity long transmission line is known as its characteristic impedance. So it is abbreviated as ZO. It is also known as the surge impedance. Okay, so we have ZO or your characteristic impedance. So this is one of sa aton nga transmission bala nga characteristic nga kinahanglan i-consider. So secondary electrical na siya nga constant ang surge impedance together with your propagation nga constant. So transmission characteristics ang line kaka-determine siya based sa aton nga discuss kanina which is primary electrical constants nga apat ka bilog, and we also have your characteristic impedance nga your ZO which is surge impedance or characteristic impedance, and we have your propagation constant. So ZO or characteristic impedance is a complex quantity, but it is expressed when Japan in ohms and is ideally independent of bisan ano pa nakalaba or anong length sa mga line and cannot be directly measured. So, hindi siya nato ma-measure bisan sa ano da nga measurement tool. Hindi siya nato ma-measure directly. So it is the ratio of your voltage to current at every point along the line. So it is also known as the surge impedance, pwede man nga wave impedance. So characteristic impedance is the impedance nga ginatanaw naton. For example, you have a line. So may ara kabi duwa ka line for example. So that makita nimo siya. For example, maltulo ka diri sa kilid, you have the line, matulo ka lang diri sa kilid, and then ang kung ano da nga um, kung ano dang impedance or ang gakakita nimo sa sina nga part that is hindi a finite nga length of the line that is terminated in a purely, for example, nga resistive load with the resistance equal to ginatawag nato nga characteristic impedance of the certain line. So okay, so if a line is infinity or infinite long sabi, it stores energy in a distributed nga capacitance and inductance indefinitely. So energy from the source entering the line never returns. So we have different formula kung paano kita mag-solve or mag-suma sa aton nga characteristic impedance. So we have ang main nila nga formula is this one. So we have R plus J WL all over G plus J WC. So wherein J natin stands for the angular difference or uh, for angular difference naton. W naton or your omega stands for your 2 pi F. G naton stand for your conductance. So, ang iba na nga mga units, medyo familiar naman ta RG, L, kag C. So, this is the formula nga pwede naton gamiton. So, take note that number one yung formula ZO is equal to square root of L over C. Ginagamit na siya naton for extremely high nga frequency. So, for extremely high nga frequency, so take note nga kung taas ang aton nga frequency, ang aton nga 2 pi FL. So diri sa dalom. So take note that aton nga 2 pi FL will be much greater. So medyo dako siya nga value compare sa aton nga R. So pwede na natin neglect ang aton nga R and 2 pi F nga value. So same man diri sa dalom ang aton nga 2 pi FC will be much greater sa aton nga compare sa aton nga G. So ang mabili na lang, so pwede na natin cancel ang R kag 2 pi F. Then there is a lalong G plus 2 pi F, so pwede na sila i-ignore. Then, ang mabili na lang will be L all over C. For high, extremely high nga mga frequencies. Okay, so next naman, we have also the formula Z, square root of Z all over Y, where Z stands for the impedance of the transmission line, and Y stands for the admittance of your transmission line. So, naka-statement na siya sa formulas if ever amo ang pwede gamiton nga formula. So, we also have ZO would also be equal to V all over I. So, provided the transmission line is infinity long. So, that's it for the formula of your transmission line. So, we are going to discuss more of the characteristic impedance lang in the next nga discussion video. And we will have more examples. So, kung paano natin i-solve and gamiton sa specific na problem ang aton nga formula. So, this is it for now. Thank you everyone. Stay safe. God bless.